Okay, so I'll be placing all of you on mute, and all of you have organizer access. Okay, so you could go ahead and actually, in case you have any questions, you could go ahead and unmute yourself and ask questions, all right? I think all of you know how to record the session. Just I'll tell you how to do it. Go to the file option on the top. You have an option for preferences there in the GoToMeeting panel. Once you go to preferences, you have a recording option there. So once you click on recording, do not touch anything with the audio. There is something called recording there. At the bottom you have something called convert to Windows Media Player file. Select that and browse to the section where you want to go and save this file. Alright. So once you do that, click OK. And then you can go to the view option, and then on the panel on the top you have the view option. Click on recording. So once you click on recording, you will have a small tab that gets enabled right above the attendee list. You can click on the start recording. Alright, so just going back to what we did yesterday, we went through the different topics we will be looking through during this training. Alright, and we've divided them into different sections, both on importance and also with regarding to certification, and also regarding understanding each of these sections. All right, all of these do not mean that they will be 1 hour sections, but depending on the importance and the understanding, we'll be spending time on each of these. We went through what we will be looking through this training. The overview of SAP HANA, where we'll be looking at understanding the HANA as an appliance and also as a database. We'll be looking through very briefly through the architecture of SAP HANA, what are the different software editions that we have, and all that during this overview section. The lesson number 2, we will be looking at the product availability matrix. Right, Nagaraj, one quick second. I will be going through the product availability matrix, which is majorly about the different servers that are available by the that are made available by the hardware vendors with SAP, and we'll also see the configurations that they offer. Not all systems, they don't have one system for every enterprise, but we have different categories, but depending on the amount of production data that you have and the replication speed. So you have different servers that are available. So we try to understand what are the different servers that are available. We'll also look at what are the different interfaces that we will be interacting with SAP HANA. It's a standalone box. You will have to bring in data, which means that you will have to have a few engines which will bring data into the SAP HANA database. We call them as replication engines. You have data services replication engine, you have SLT replication engine, and then you have the Sybase replication, and also direct connection extraction. So all of these are different replication methods to bring data into the SAP HANA. So we'll see what interfaces they will be interacting with the HANA appliance. Right. Lesson number 3 will be architecture. We'll be looking at architecture from different perspectives. The architecture as an appliance as a whole, trying to understand that. And the important topic will be the SAP HANA database engine view. We'll be looking at the database is not just one single database like you have it on SQL, and you have different engines that work together for the database to work, and you have the index server, which is the most important of that. So we'll break it up into different servers, and then we'll try to understand how these are integrated with each other, what exactly happened, how calculations happen, how searches happen, and all that. So how the health of the system is maintained, the topology of the system. How do you connect different servers, like let's say for a direct extraction method, what is the access engine, what is the functionality of that? So there's so many different managers, transaction manager, metadata manager, authorizations, administration. So we'll try to take a look at that aspect in tomorrow's section. Then you have the data loading view. So I told you about data being brought from different sources, and then you will be loading data into the SAP HANA box. We'll try to understand what are the different options or where the interface is happening. This is on a logical basis, how do we connect it to the SAP HANA box. that will cover the data loading view. Then you have different models that you can go ahead and create with SAP HANA, and we will be discussing that during the data modeling, right? Attribute, analytic, and calculation view. What are the options that we have? How good are these models when we're dealing with them? Because all of these models that we create with the SAP HANA are views. Majorly, we're defining joins and we're not actually persistently loading data into these models. So how do these function? Because you have three layers of them. So you have three layers of views that will get materialized at runtime, and they'll be consumed by the reporting layer. So we understand how each of them functions. On the reporting front, we will understand as to what's the interface that the SAP or SAP HANA does not have its own reporting tool, but all the reporting tools that have the connectivity, like the Business Objects Enterprise portfolio of reporting tools and MS Excel. We'll be looking at how these will interact with the SAP HANA database. You have different methods connecting directly to the HANA database and also connecting through the semantic layer using the information design tool. So we'll be looking at both of these options, which we'll be seeing here very briefly on the architecture that is there. On the administration view, since you have so many users, you will be looking at authorization for the users and also the roles that you could create, and also as an activity for administration. And since we are dealing with volatile memory here, we will understand at the administration how do we do backups and how do we do recovery. So in case there is a system failure for the volatile memory, what are the options that you have, what is the backup that you can create, is what we will look. So let's say you have a backup of a disk, a physical disk that you want to write. So what happens in case that disk crashes, right? Apart from the HANA system crashing, or in case the disk gets crashed. And can you recover data back, or is there another system that will be a backup for a backup? So all this we will be talking through during the administration. The SAP HANA system landscape is not like the usual landscape that we have, where we have three different boxes for dev, quality, and production. We will have one system or one box, and we'll have different environments on the same box. These are handled through the different hosts in which the SAP HANA will be installed. So we'll look at how you can, how different it is to have multiple hosts on the same server, and how we can move objects across. We'll also need to understand the SAP HANA sizing guidelines, where we try to understand what are the options, what kind of RAMs we should be using, because whenever these discussions happen with the client, you should be able to understand and able to contribute to what servers you should be using. So we'll look through the system sizing guidelines as well, the RAM sizing, the database sizing, and all that. We'll be looking through that. And data provisioning is the method of how you move data from non-SAP or SAP databases or systems or applications into the HANA database. For that, you have four different methods: data services and SLT replication, which are very widely used. Apart from that, you have another two, which is the Sybase replication, specifically for customers who have called on an invite from SAP. And then you also have the direct extraction connection, which is a new method of how you can extract data. Does not opt or give you the real-time replication, but gives you the option to still replicate your data. Right. So we'll look at those options as well. We'll be spending a lot of time on data services and LT replication, but we'll be looking through what is the mechanism for Sybase replication and the direct extraction connection replication as well. Now, SAP HANA Studio is the interface that you will be logging into when you're using the SAP HANA. Your modeling, administration, everything will happen with the SAP HANA Studio. Right? So there's a lot of new terminology that you have, a lot of new functions that you can do with the SAP HANA Studio. So we'll understand that on lesson number 7, what is the functionality of each of these individual tabs, and we'll look through that. Lesson number 8 will be HANA modeling, we will be discussing about the three different models that we're using, the attribute view, the analytic view, and the calculation view. The attribute view and the analytic view basically can be compared to BW to the dimensions and the star schema, the analytic view to the star schema. The calculation view can be compared to a virtual provider or a multi-provider. Has two different methods of creation. One is a graphical method, one is a scripting method, where any complex joins that you want to define, you are not able to do that in the analytical view. You can define that with the calculation view. And so we'll look through that as well. You have a lot of computing engine functions, predefined and reusable functions that you can use with the calculation view or with any scripting. Since we're looking at these models, we'll also look through as to how we can export and import these models at the server level, client level, and also at the transport level. All right, so if you have a landscape and then you need to move it from a dev to a quality environment or from one system to the other, then what are the options that you have when you're doing your exports of objects? Can you group your transports? Can you group your objects? All of these we'll be looking through at export and import. Once you've defined the model, that is, your data will be stored in SAP HANA only at one layer, that is the persistence layer, and from there they're all views, right? So you don't really physically store data anywhere, but the joins enable you to go ahead and materialize these at the time of run, and you're consuming these models at the reporting layer. So in lesson number 9, we look at the integration part with business objects with SAP HANA database. Can you do a direct connection? What are the different tools that will adapt to connecting directly to the SAP HANA box or the SAP HANA database? What are the different tools that will be using the semantic layer, which is the universe created from the information design tool, right? So here we will look through also the visual intelligence, another proprietary tool that is used over the SAP HANA box for exploration. So we'll look through that as well. Lesson number 10 and 11, we'll look through user management. Basically, we try to understand if we have a single sign-on concept in HANA, can we bring in profiles from SAP to be used with SAP HANA, or can we go ahead and use a single login for the SAP business objects and the SAP HANA box, right? So for actually authenticating into the SAP HANA system, you have another protocol, or you have another encryption protocol that you can use, which is called Kerberos. So we'll try to spend some time understanding that as well. Can the authentication be handled outside the SAP HANA system, or should it be only handled inside the HANA system? What options do we have? So this slide basically deals with the development segment of what we'd be looking through training. Coming to the administration part, we'll be looking through as to how we can install the SAP HANA client, the studio. How do you download it from the service marketplace, and what options do you have? What operating systems does it support? And how do you extract these files? So we'll be looking through that. We'll also show you slides as to how the installation of the SAP HANA box happens. So then you have on lesson number 13, the SAP HANA Appliance Enterprise Server, your scale-up configuration and scale-out configuration. Usually you'd calculate the exponential increase of production data over the time in the next 3-4 years, how your data is going to be exponentially increased. So based on that, you will prescribe the server. Sometimes your data that comes through will be a little more than expected in those scenarios. What is the plan is what is scale up and scale out configuration deal with. So can you increase a vertical increase in the server by adding more of the CPUs or cores? So how can you handle that? And the scale-out configuration is usually used by larger enterprises where you try to add more servers and do a horizontal increment in the landscape. So when you do that, now again, your search criteria, your database instances, all of that has to be divided. So how do you handle that is what we will be looking through in the scale-up and scale-out configuration. Again, there are a lot of servers I told you within the HANA database, and for interacting with each of them, you have different port numbers. There is a new set of port numbers that are used with HANA, 5 series, right? And each server has a different port series that you can use with it. So on lesson number 17, we'll try to understand the port numbers and how the transactions handled, and then which server interacts with which server, again from a port perspective. In case there is a failover now, are there different nodes that can take over a particular server's functionality? So we'll be looking through that at lesson number 17. Again, disaster tolerance hardware, there is always a possibility that the server might fail by some natural calamity or in case of a system maintenance. So what options do we have? Because we're dealing with data that is there on the main memory. We're not physically writing data to the physical drive. So if a system crashes, then it means that your entire main memory is wiped out. So in those scenarios, what options do you have? What we'll be looking with disaster tolerance, your hot backups and cold backups will be discussed in here. Multi-version concurrency control is where you will want to have one single version of truth, where there are multiple transactions sitting on the same table or same row, and then the user is trying to use, does he have one version of it, or how does the system handle that? Is what we'd be looking at, multi-version concurrency control. This is not a new topic. On any database, we'd still be using this, but how do you handle that in HANA is what we'll be looking at. Okay. The persistence layer is where we'll be writing all the data that we bring in from different replication engines into the SAP HANA box. So what options do we have at the persistence layer, right? So is what we'll be looking at, the persistence layer. The backups and recovery are again administration topics where we'll need to understand what is the minimum save point that you need to have for taking a backup. What are the best options to have backups? And in case of a failover, how fast can you recover your data back from a physical drive into the RAM again, or the main memory again? What options do you have at startup? Can you load in case you're starting off a server again? Can you load your tables back onto the row stores and the column stores directly, or do you have options to store the load data for the row stores first and then later on to the column stores? All these options we'll be looking through. Special emphasis on SLT replication data services. We'll be looking through a COPA business case through the training. So whenever there is an implementation, usually SAP chooses a COPA implementation or a COPA business case. So we'll be looking through that, trying to understand reports of COPA. And yeah, so that should be something like a little heads up for you before you appear for your interviews on SAP HANA. Your security and authorization, again, so a lot of your security is handled through SQL editor. So we'll see what are all the security options that you have, what are the privileges that you can give for every user, how they are combined in the role, and how the role is actually given to a particular user. So we can look at that. The role of solution manager for handling updates and upgrades in the SAP HANA system. So we'll be looking through how the solution manager is placed in the landscape. And on lesson number 28, when using HANA as a database, what are the changes that you would have on the SAP BW as an application? Because SAP HANA supports star schema, BW supports extended star schema. So how great is the change that we'd be looking at when using SAP HANA under the SAP BW application? Now, the roadmap of SAP is that they're going to use a unified HANA database under every application that SAP provides, and which means that all of these applications should be able to adapt to the SAP HANA database or the star schema. So we will try to understand how BW is able to apply this, the SAP BW application, what changes you'd have on the info cubes and the DSOs at the application layer. So we'll look through that. Then we'll see if we have time. We'll be looking at a few accelerators and the rapid deployment section as well. How you handle that with SAP HANA. Can you create applications for mobile usage with SAP HANA? So we'll talk a little bit on that as well. All right. So and just to go and look through all of these topics, we will look through the certification dumps as well, so that makes it a little easy for you to handle certifications, right? Okay, this is a little picture of where HANA is placed. The SAP HANA is the in-memory database that you use, which is placed between your extractors, which are nothing but your replication engines for bringing in data from different SAP or non-SAP systems. On the other side, you have your reporting tools or clients over the SAP HANA database. Now, I mean, this is something we've seen yesterday, guys. If you're there yesterday, don't get a little bored. We'll catch up with what we'll be doing today. So the SAP HANA box does not generate data by itself, or just does not generate data. It has to get data. So any system which would want to see reports a little more quicker than what you have on BW or the OLAP system, the usual method is to move all your transaction data at the end of the business day back into the OLAP system through extraction methods, and then you run your reports. So you're basically looking at your reports the next day. In case there is data that cannot really wait, that data will be sent to the SAP HANA box. So it's not the entire data that you will be sending through the SAP HANA system, all right? And majorly all your calculations and your quality, all that is handled outside the SAP HANA box. The cleansed data and the transform data is what you're pumping into the SAP HANA database. You don't do a major calculation inside the SAP HANA box. But it has the ability, but you would be doing majority of your transformations and calculations outside the SAP HANA box. So the engines should be able to support transformation capability, cleansing capability as well. All right. So that is something that you should be looking at. Now, the reporting layer is placed right on the SAP HANA server. Again, I talked to you about the different methods. One is direct connection to the HANA database. The other one through a semantic layer. So we'll look through that in detail. The definition for, or how SAP has defined it, is a flexible data source agnostic appliance that enables customers to analyze large volumes of SAP ERP data in real time, avoiding the need to materialize transformations. It's a combination of both hardware and software, as what we've seen yesterday. The hardware provided from the vendors and the software from SAP. It's a combination of both, with a lot of new features added up from both hardware and software. Both of them implemented completely as a full-blown implementation on the SAP HANA server box. So your data is not stored like in a traditional approach on a physical database, but it is stored on the RAM, on the main memory. All right. So whenever you're talking about writing your data onto the main memory or bringing data from your main memory, it's much faster than what you have to do from the disk storage. All right. The reason for that is usually what happens is the architecture is you have an application layer and then you have the database underlying. So every time you fire a query from a tool or from a client, the application layer has to check on what is the kind of data that they want, the subset of data. It has to go to the database, which is again a physical drive. It has to go to that location. The disk is spinning on a spindle, and it'll have to locate that the position of that set of data. It has to bring that back onto the application layer where your calculation is happening, and then you're pushing that to the reporting layer or to your client. But here, all your data is available on the RAM, which is main memory. All right. So I'll show you also a picture as to how your timings will be changing and the improvement on timings that you would have when you're storing data on the main memory. You have faster access if you're going to the registers also, but they cannot store huge amounts of data. Right? They are faster than the main memory, but you do not have the capability to store huge amounts of data, at least till now. So using the main memory, and since your main memory has become cheaper now, your RAMs and all that it's not as expensive how it used to be. So we'd use this innovation from the hardware side. And the HANA system is trying to bridge the OLTP and the OLAP method by combining both real-time transformation accessibility into HANA and also your modeling capability with the SAP HANA Studio. So you are pretty much bridging the OLTP and the OLAP systems with the SAP HANA system so that you can make decisions at real time. Alright, so I was talking to you about the innovations from the hardware technology, the multi-core architecture that we use here, multiple cores and then multiple CPUs and then blade servers, all that. So we'll look through today's session as to how these can be accounted for the time increase or the improvement in the reporting speeds, how they can be accounted for your parallel processing and all that. Alright, so on the innovations of the SAP software technology, you have the row and the column-based storage. The row store is an acquisition from SAP from the P-Time database during 2005. The column-based storage is not new. It is, again, taken from the Trex implementation with BW Accelerator. So here you're basically reading through columns rather than through the rows. So it gives you a lot of improvement during your fetching of data, right? So for capturing data and reading through back, it is very fast, right? But it does not have the same capability when you're handling inserts and deletes on the column based. Okay, so you have both row based and column based also connected to each other through indexing. Okay, so you have this capability in here, and the column base gives you a lot of option for storing huge amount of data in a smaller space. So you have high compression ratio, almost 1:5, between 1:5 and 1:10. So on an average, you have 7 as the compression ratio with the column stores, and you have partitioning as a part of the software. You don't have to do any aggregates like how you do it with BW, where you are trying to guess what kind of data is coming through and then try to go ahead and load that data through. So that is an added advantage. Your data is always available at runtime with SAP HANA. We have 3 software editions depending on the customer and the licensing. You have the platform edition, which is core HANA software. Then this is for customers who have who are SAP customers and who also have the replication licenses for data services and SLT. Then you have the second set of customers who are SAP customers but who do not have the licensing with data services and LT replication. So as a part, the enterprise edition has the combination of the core HANA set plus the replication service. We'll look at that in detail. Then you have the extended or the enterprise extended edition, where you have customers who are non-SAP customers who would want to use, or for them they need to have the packaging is done with the core components of HANA. Apart from that, you have the replication engines, and also you also have the Sybase set of replication engines also packaged along with the extended enterprise extended edition. We spoke about the architecture here. Basic division on the architecture is we have 3 major segments here. One is the sources that you could use with SAP HANA, the HANA appliance altogether, and then you have on the top here reporting clients that hit the SAP HANA database. This we divided into 3 major sections: the SAP HANA, First one being the replication part, where you have real-time replication services. We also call that as Sybase replication services or log-based replication services. You have the SLT, SAP's Landscape Transformation Server, and you also have data services as another mode for replication. All right, the real-time replication services used by Sybase is for database replication into the SAP HANA system. Uses, or you call it as a log-based replication, uses the logs from the replication or from the database and uses them as transactions in the HANA system to generate the data. The SLT replication method uses the SLT server, which is used for migrations usually between different landscapes in SAP. So you use that interface to move data from the SAP or non-SAP systems now into the SAP HANA database. Right? So here we have the SLT replication, and then you have the third one, which is data services mode of replication, where it supports both SAP and non-SAP system, handles transformations and cleansing as well. So this is the only ETL that is able to connect to the SAP HANA database. You cannot connect through any other ETL. Right? So data services is the third mode of replication that you could use. Calculation, and right above that you have the heart of the SAP system, which is the in-memory computing engine, where all your calculations and planning consists of the calculation and planning engine. And also the row stores and the column stores. Right? The calculation engine basically is not calculating, it's basically trying to transform or translate your different queries that come from the layer from the client layer, which is your reporting. It converts either MDX or SQL or BIX form of your data into the native SQL that HANA can use. Right? So in case you have a bigger query, the SQL parser breaks the query into smaller segments so that you are able to bring in the report or your result at a quicker pace. If you're bringing in something from MDX, you have an MDX engine which converts the MDX to an understandable SQL for the HANA system. Your calculation is handled there. Your planning functions are also handled by the planning engine, not full-blown planning, but basic planning things you can handle with the planning engine connecting to your financial applications. The row store and the column stores are basically where you store your data. That's again in the main memory. And you spoke about the column stores. Again, those are combined together. So you are able to give your result back in the form of rows when you're dealing with the clients that you're from where you're actually firing your queries. Right above the in-memory computing engine, you have the modeling studio, where you have different models, the attribute view, the analytic view, and the calculation view that you design in here. This is again completely in the studio, basically defining joins and the direction of the joins so that you are able to materialize these views at runtime. All right? And so this is what you majorly do at the modeling layer. These models are consumed at the reporting layer by the different reporting tools. Right, so this is very briefly about the architecture of what the HANA appliance is. We've seen the different applications that can connect to the SAP HANA box, the interfaces that we will be dealing with, the SAP HANA Studio, the client, the host engine, the data services designer, information designer. Then you also have the different reporting tools. So just a little picture as to what are the interfaces we'll be dealing with. Again, from the vendor perspective, this is a chart which will show you the different vendors that are providing the servers for the SAP HANA box. You have the list of vendors in here, the CPU, the CPU configurations, the memory configurations, and the file systems that you're using with the operating system. The operating system always that is used is the SUSE Linux Enterprise Server 11 Service Pack 1. That's the operating system that we're using on the box. Some of the partner vendors that you have here who are providing the SAP HANA Blade service. The sizing guidelines, the servers that are available for different enterprises basing on the uncompressed production data and the replication data load or replication speeds. So you have different servers. So extra small, small and medium are the three major servers that you have. Apart from that, you also have the large and extra large servers that are available as well. All right. The SAP HANA Studio is the interface that we'll be working on. I'll walk you through a little of this today. Right, so what we wanted to do, so that is what we covered yesterday. Today's section we will look at how the terminology of HANA is used. So you don't use it as a single terminology as HANA, but you always prefix it with SAP. You call it as SAP HANA. If you're using it with an appliance, you call it as SAP HANA appliance software. If you're using it with a database, you call it as SAP HANA database. If you're using it on a cloud, you call it as SAP HANA application cloud. If you're using with, if it is an application is using SAP HANA's, then you call it as the application powered by SAP HANA. For example, you have SAP Smart Meter Analytics powered by SAP HANA. So anyways, you call the SAP HANA Studio or the studio as SAP HANA Studio, and when we're referring to the platform of SAP, we call it as SAP HANA Platform. So whole point is always use HANA combined or prefixed as a part with SAP. All right. So basically, whenever you're dealing with the SAP HANA box, you will only be moving data. Why do we need an SAP HANA box? Basically because we have a solution from BW as an OLAP solution for SAP. But what happens with BW is we are not able to provide reports at real time. Okay, so we are at the end of the business day. The transactions for that day are transferred into the BW system. We call them as extractions. We have the process of extraction, transformation, and loading. By the time you're looking at your report, it's tomorrow. Whatever is happening today, you're looking at the report tomorrow. So to take a strategic decision by a decision maker, it gets difficult because you are having so much time in between from the day's actual factual happening and the strategy that is taken after you look at the reports. But now they do not really want to wait till tomorrow to look at the reports in case somebody loses $1 million. He wants to see that he's lost it right then and there, not wait till tomorrow so that he can make some strategic decision in how he can change his business model or business plan or strategy of how his market should work. So he doesn't. They do not really want to wait for the data to be reported till tomorrow. So data that really cannot wait till it happens, till it is reported tomorrow, that data is to be moved into the SAP HANA box and not everything else. It does not offer the modeling capability just like BW, but gives you pretty decent modeling that you can handle, right? Again, these are consequences because of which you were using the SAP HANA box. Suboptimal execution speeds because of BW, lack of transparency, and reactive business model. HANA is a proactive business model, and it is very transparent because of the star schema and the major joins. You can see where data is actually spread across. You don't have to do any aggregation with SAP HANA. You have the aggregations already defined, or your aggregation, basically your data is available on the RAM, so you really don't have to do any aggregation. And you don't have data on which you're actually again, lack of responsiveness and user frustration also is a part of the execution speed because of slow speeds of execution. All of these are the results. Coming to the hardware innovations, we spoke about the core yesterday. The core is a part of the CPU which does the major calculations. So we've seen about single core systems, laptops. Then later on we've looked at multi-core, which is like dual core processors on the laptops. Now what happens is when you have a single core, the core is doing all the processing or the basic calculations on a system, all right? And the number of cores increase on the CPU, then it is, again, it almost acts like parallel processing, all right? If you are able to process 1,000,000 records on one core, then if you have 10 cores, then you are dividing the whole thing by 10. So the execution time for handling all of that is parallelly done. Okay, on a database, if you're looking at the rows that you have on the database, the rows are independent of each other. All right. So when you take a core, the core is able to split based on the number of cores. It is able to split the database so that it can handle individual operations on the CPU. Okay. So if you have 1,000,000 records and 10 CPUs and 10 cores, so your 1,000,000 rows are partitioned or divided into 10 subsets, and they're processed by individual cores, right? So now the innovation has come to the level where you can accommodate 10 cores on one CPU, okay? And so that's the first level. Then you have the board servers where you are able to have multiple CPUs on single board, all right? So if you're looking at 8 CPUs on one board and each CPU is having 10 cores, so you're looking at on each board you're looking at 80 cores, all right? And if you're looking at blade servers, the blade servers can accommodate multiple server boards. If you're looking at 4 boards, then you have a total number of cores as 320 cores, right? So that is the capacity that you have with the HANA servers. And your RAM that you're using, you have massive expansions on RAM. You can accommodate up to 4 TB RAMs. I'm not talking about hard drives. Your RAM itself is 4 TB. So you are able to accommodate so much data on the main memory itself, right? So that's what you have with the hardware innovation side. Now let's try to understand the column stores a little bit. The basic column, so you have column stores, row stores and column stores. You understand what are row stores. Basically you would have data stored on the database in the form of rows, which we are used to, which is the traditional approach. You take a table and then you find this data. You have each of these rows is called as a tuple, all right? And these tuples, whenever the system tries to read the data, it goes from the left to the right, has to come back to the left again and go through reading to the right. So whenever you go for a search, so there is a read from the left to the right. If it is not, the record goes back here. And though it doesn't seem like a lot of things, when you're looking at millions of rows of data, there is a cumulative increase in the time because of this particular left and right read, all right? And but the new concept is using column stores where you don't really read data from left to right, but you're reading data vertically, all right? In the column store, you're reading data in this fashion, all right? So let's say you given a query for you want to look at customers who are customer number 300. So if you're looking at a row store, what you would do is you go from the left to right, and then you complete 1 row, 2 rows, 3 rows, and then you come to the 4th row. And in this process, you're actually looking at individual left to rights as well. But if you're looking at a column store, you're doing directly a lookup directly onto the column itself, and you're going 1, 2, 3, 4 directly down on a vertical read. So whenever you get to that 300, you refer to the remaining parts of the column which are stringed by an index, all right? So the column stores are much faster to read from when you're comparing it with the row stores, right? So all your models that are created inside the SAP HANA, your attribute view, your analytic view, and your calculation view always deal with the column stores, or your data is stored as column views than as row stores. Also, you have the capability to swap your row stores and column stores whenever you want to in the SAP HANA system. All right. So you can change a row store to a column store, or a column store to a row store as well. Now the advantage with the column store is also that, let's say you have a customer, you're looking at master data in here, your customer, you have three, actually you have 1, 2, 3, 4 rows, but your actual storage of customer is only 3. If you're looking at country, though you have 4 entries in here, but the identical or the unique entries are only 2, so you'd have only 2 rows in there in that column. And if you're looking, and then you have the product as well. So you have 4 values in here, but unique values of only 2. So you'd have only 2 values in your column store. Only for amount you would have all of these occupied in the column store. So basically, you are storing lesser than you used to from the row stores on the column store. Right, so there's a lot of compression ratio when you're dealing with column stores. You have almost a column a ratio of 1 to 5 or 1 to 10 that you could have with the column store. So that is a lot of added advantage that you have with column data storage. Here, traditional approach of dealing was you basically do your calculation at the application layer, and then what's happening here is at your application layer, whenever you fire a query, the application layer is actually taking that query. It handles your transformation, handles your cleansing, calculation, all of that at the application layer. It's a lot of performance hit because of the amount of application or the amount of different things that it is doing at the application layer. In case you fire a query for a result of a particular set of data, the application layer takes that query and checks in for what data it needs. It goes to the database layer, fetches that segment or subset of data, brings it to the application layer, does your calculation in there, and then finally moves that to the reporting layer. But in your approach here with SAP HANA, you're trying to push down everything onto the database layer, your calculation onto the database layer. All right. So your application layer is majorly transferring the results onto the reporting layer, then actually doing your calculation inside it, right? So this is the approach that we're looking at with SAP HANA, right? Again, remember when I say calculation, it is not major arithmetic calculation. It can handle arithmetic calculation, but not majorly arithmetic calculation, all right? So the system is able to even handle parallel processing and partitioning, and can control individual processors and cores as well. So you have the number of cores. Each of them can be burdened individually with a particular subset of data for them to process at the time of execution also. So you have let's say you have, if you look at the first layer, you have table 1 and year, or year is the component that you are using, and for partitioning, then year P. So you can also partition your data based on the number of cores that you have also, so that you are handling parallel processing, and you can have data spread across multiple blades as well. So we've spoken to you about the hardware and the software side of the SAP HANA together, what they're trying to bring in. But here what we are looking at is that SAP HANA is not trying to experiment something new with the in-memory capability. It's not the first time that they're using. They had other applications that use the in-memory capability, and SAP HANA is a complete full-blown application that is using the in-memory capability. All right. So you have so the in-memory applications previously used were you had the BW accelerator, using the in-memory capability. You had the Trex engine inside that for search and classification, which was used for improving the speeds with the reports in BW. Then you have the live cache technology with APOs. They're also using the in-memory capability as well. But HANA is the next generation system where you're using the in-memory as a complete blown implementation in the SAP HANA box. So this is how today's situation is, where you have how the ECC system or the ERP system is placed on individual databases. Usually we use either Oracle or SQL. That data is moved to the enterprise data warehouse, having a database, and under that you have the BW accelerator for speeding up your reports for the corporate BI. Right? Now this is what they have with the first version of SAP HANA. You have individual HANA located at each of these, which is increasing the reporting speeds individually. And also you have BW Accelerator in combination also with SAP HANA. But now there will not be any more BW Accelerator. It still supports BW Accelerator, but heavy discounts are given for clients who are using BW Accelerator to move with SAP HANA books. All right, so it will be time before all of them start using the SAP HANA appliance for improved speeds. But this is not where they ended. They wanted to go ahead and push to have HANA over the entire BW enterprise, replacing BW Accelerator. So you don't have any more BW Accelerator with Service Pack 3. You would have HANA replacing that, and it will be used both at individual data marts of systems and also the enterprise data warehouse. HANA is used for improving the speeds in there on the corporate BI level as well, and also on any other application that you use. Now, where they are looking at the roadmap is to have one unified database across the entire enterprise. Any application that is using SAP will be placed on the SAP HANA database. You would have different schemas individually for each application, which you can use. So this is where the roadmap is for SAP HANA. So we still do not have a model for ECC with HANA yet, but talk is that it's going to come pretty soon. So these are again the server specifications of different vendors who are providing the servers: Dell, Fujitsu, HP, IBM. Right, these are the servers that they're using. The Nehalem processors are the next generation processors after i3, i5, i7 processors that you have. You have Nehalem processors. Then after Nehalem, they also have the Westmere processors, which are the next generation to Nehalem. All right, and all of these servers are on the operating systems SUSE Linux Enterprise 11 Service Pack 1. They do not have a Windows version yet. It is announced, the ECC on HANA is announced, but it is not a full-blown thing as of now. Right, Nagraj. All right. So with, again, the Westmere process is a screenshot of the Westmere processes that are used with, again, large and extra large servers as well. Some of the components that are used with the HANA database or with the HANA appliance, you have the in-memory computing engine, IMC, which is the heart of the server. You have the clients. Now you will have different servers inside the system and they have to communicate, right? And for that you have different sub-components, which are the IMC ODPO, which is OLEDB for OLAP. Then you have IMC ODBC, which is predominantly used in the industry, Open Database Connectivity. The IMC JDBC, Java Database Connectivity. IMC SQL-DBC, again SQL Database Connectivity. These are the four sub-components which will help you to communicate with other components in the SAP HANA appliance. The SAP IMC Studio 1.0 includes also the SAP HANA Modeler, where you do majority of things from the SAP HANA Studio itself. You have the Sybase Replication Server 15 and ECDA, Enterprise Connect Data Access from Sybase. Again, you also have a Sybase Replication Agent, the Load Controller, and the SAP Host Agent 7.20. Right? So these are the different components that you have with the SAP HANA system. So let's look at the different editions. We've seen very briefly about what are the different editions that you have with SAP HANA. You have the platform edition where the core components of SAP HANA are given. The SAP HANA database, HANA Studio, HANA Client, Host Agent 7.2, and the HANA Information Composer. Now this is for customers who already have the SAP are already customers with SAP, and they also have the licensing with data services and could use the LT replication server, whichever they want for replication of data. But the components of the core SAP HANA appliance, these are the ones that are given for the platform edition customers. For the enterprise edition customers, these are again SAP customers who have who do not have the licensing with data services or the LT server. So as an addition to the components from HANA, they will have the LT replication add-on, the LT replication server, and the SAP Business Objects Data Services 4.0. You have also the option to use Business Objects Data Services 3.2, but you have a complexity when you're using Data Services 3.2. So it is always better preferred to use the 4.0 than the 3.2 whenever you're dealing with the SAP HANA. Now for the customers who are not SAP customers and who still want to leverage the usage of the SAP HANA appliance, they have the full-blown components that are delivered to them from SAP HANA and also from the replication side. You have the LT replication engine, you have the data services replication, and also the Sybase replication. All of them are delivered with the Enterprise Extended Edition. This is the this is for non-SAP customers. Some of these are the statistics that you have. The improvement in speeds. On a BW system, it's taking 77 minutes for execution of a report, but with SAP HANA, it is 350 times faster, with taking 13 seconds for the execution of the same reports. Right? With HANA, you can almost analyze 460 billion records under a second because of the number of cores that you have. So some of the statistics that you have from different clients. We're not doing architecture now, but I'll just show you the statistics of how your hard disk is the last option, non-volatile storage of data. You have the SSD flash drives and the hard disk as the storages for non-volatile data, that is you're writing to a physical system. But the second option, which is the volatile memory, here you have the CPU registers, the CPU cache, and the RAM. Right, the amount of the increment in speed is almost, you can look at it, 2000 times for SSD flash drives and 150 times from flash drives. So you're looking at a great improvement in the speeds when you're dealing with the RAM. You also have the CPU registers and the CPU cache, but you will not be using that because they cannot hold a lot of data. Right? So we will be going with RAM, and because of the improvement in hardware, you can accommodate huge amounts of data on the RAM itself. Alright, so this is how it all started, or it is not a new approach for SAP HANA for in-memory capability. Using the search and classification engine, Trex engine. Then you had the BW Accelerator 7.0, BW Accelerator 7.20. You also had the live cache, again with MaxDB, row stores with p-time, database acquisition, business objects accelerated, all of these together, all the components together, they're using the full-blown approach for SAP HANA. All right. So this is what we have for today's session. We will be looking at complete architecture from different perspectives, majorly from the database perspective, so that you understand how exactly different servers function inside the HANA database and how your basic searching happens in the SAP HANA system. All right, so we'll look at that in the next session, in tomorrow's session, and we'll also look through the HANA Studio as well, trying to understand a little bit about the HANA Studio. All right. So any questions?
Hi, Manuel. So can you please go to the column store slide, how the data is storing in the columns?
One moment.
Yeah.
Yeah.
Okay. I'm not, okay. Here, for example, can you please open that slide? So I'm not able to see. Okay. For example, if the data is storing in the row based, so if I select a query, select amount from the table where customer number equal to something and country equal to something, then I will get one value. So if the data is storing in the columns, how this query is calculated?
You're basically reading through columns here, all right? So
Right.
you have a string running through individual columns again, okay? So they'll string to bring in this value again, and on the underlying, both the row stores and column stores are also connected. So when you go through the read, what happens is you read through the column. So you mentioned, right, for a customer something and a product and a country something, you want to know the amount. So
Right.
you first go through the country, so the customers. So you're reading through 300. Let's say you have to go till 300. So you're going to 300. So you understand that 300 is the row that you're looking at. Okay.
Okay.
So for 300, you might have different countries. So it will look for the searches on the countries that are available with 300, and whichever is the country that you have with 300, and whatever is specified in your query, it will look for that. Again, a vertical search. And then it will bring out the amount from that particular row. The index will help you to capture that entire single row to be brought onto the application layer again.
Okay.
All right, I'll just show you a screenshot of that. Just give me one quick second.
Okay.
All right, so if you can see my screen, your basic reads are happening this way, all right, from left to right and back here. So that's how your search happens. But if you're looking at column based, then you're going from top to bottom, okay? And this is how your search happens.
Okay.
All right. So based on the query, it will go and check for whichever is the specific. So if it is not here, it goes to the next column. So that's how it starts your search off with. So wherever it gets your value, it stops there and then tries to pick that row through the index.
Okay.
All right. That's how the column store functions. I will talk you a little more to that I have a few more slides that I can show you as to how you're able to improve the speed for in the column-based stores. But this is column stores are majorly better for reading your data than actually doing an insert or an update on the data.
Okay.
All right.
And what is the timing for tomorrow's session? So same time or?
I'll try to go ahead and do it a little earlier than what we're doing today.
Okay.
All right.
Yeah. Okay.
All right.
Yeah. Thanks.
Right, guys. So I'll see you tomorrow's session. I'll be sending you the timings as well, so you can join in for the session. This is all right. Then have a nice evening. Sorry about being a little on the later side. Uh, I guess so. I'll send you the invite for tomorrow's session.
And please
Take care
send the
and
today's PPT too.
sure, I will. Yeah.
Yeah. Thanks.
Right, guys. Yeah. Bye for now.